Hello, and welcome to part 2 of the module that provides an overview of the JAWS web server case study. In the previous part of this module, we described the pattern-oriented JAWS web server case study. Now, we'll turn our attention to describing some of the key patterns that make up the pattern-oriented design of that web server, focusing primarily on the portions called the event dispatcher. Naturally, these patterns can be applied to many other kinds of servers and other types of concurrent and networked applications. All the patterns we'll be describing here, with one exception, come from the Pattern-Oriented Software Architecture Volume 2 book, which focuses on patterns for concurrent and distributed objects. The first set of patterns we'll talk about can be grouped into service, access, and configuration. These patterns are intended to effectively design and configure application access to interfaces and implementations of evolving services and components. We'll also talk about a number of patterns related to event handling, which is intended to simplify the development of flexible and efficient event-driven apps. We'll also talk about concurrency patterns. These patterns are intended to enhance the design and performance of multi-threaded concurrent and network software. And finally, we'll talk about patterns that are grouped according to synchronization. And these patterns are intended to provide flexible solutions to common problems related to synchronizing concurrent software. If you take a look at the POSA 2 book, you'll see that there's 17 patterns in all, and we'll be covering 14 of these patterns in this discussion. You can find out more about POSA 2 and the other POSA volumes here at the website at the bottom of the slide. So let's talk about the different challenges we face when developing JAWS, and we'll discuss some of the patterns we can apply to address those challenges. The first set of challenges we're going to deal with have to do with trying to encapsulate the tedious, error-prone, and non-portable C-level interfaces. And to do this, we'll be applying the wrapper facade pattern. Wrapper facade is used to provide object-oriented class and object interfaces to these low-level C APIs. Next, we'll talk about ways of being able to decouple event demultiplexing, connection establishment, and service initialization from the actual protocol processing we're doing with our web server to send and receive various GET requests and POST requests and other types of HTTP requests. In this particular case, we'll be talking about some event handling patterns. We'll be talking about the reactor pattern, which is a pattern for being able to separate the low-level arrival of incoming events from the dispatching of those events to appropriate handlers. We'll also be talking about the acceptor connector pattern, which is a pattern for decoupling connection establishment and service initialization from protocol processing. After this, we'll start dealing with issues of scaling up the performance of our web server in order to be able to take advantage of multi-core and multi-processor platforms. To do this, we'll apply the active object and half-sync, half-async patterns. These patterns allow us to have pools of threads that can be mapped to the underlying hardware resources and operating system abstractions much more scalably and much more efficiently. As we talk about half-sync, half-async, and we talk about active object, one of the things we'll have to do is provide a way to have access to a synchronized request queue that can be put and get by multiple threads concurrently. In order to do this, we'll apply the monitor object pattern. This pattern ensures that only one thread of control is active within the state of a particular object at a time. We'll next discuss an alternative pattern for concurrency. This pattern is meant to make the concurrent processing more efficient and more predictable relative to half-sync, half-async, and the use of active object. This pattern is called leader followers, and it gives us another way to allocate and manage pools of threads that has lower overhead and less context switching, synchronization, data movement, and so on. We'll then kind of switch gears and talk about asynchronous ways of handling events using something called the proactor pattern. The proactor pattern makes it possible to be able to leverage the underlying asynchronous I/O operations that are available on certain operating systems that can give you tremendous performance boost without using lots of threads. Next, we'll talk about a variation and an enhancement to proactor, which makes it possible to demultiplex and dispatch the completion of asynchronous operations when they're finished. Next, we'll talk about ways of being able to make our web server more flexible, more configurable late in the design cycle at installation time or even during runtime being able to bring in different services in small parts, being able to link in different implementations of the web server that are tuned for the particular context in which it's running. To do this, we'll apply the component configurator pattern, which makes it possible to dynamically link in various pieces of an application or service later on in the lifecycle. We'll also next talk about a pattern that does not appear in the POSA 2 book. This pattern actually is briefly summarized in the POSA 4 book and also appears in a paper that you can get from my website. This pattern is dealing with ways of trying to minimize the utilization of resources when clients are not actively accessing those resources. And the pattern is called the activator pattern. And we'll talk about this pattern and illustrate how to apply it to JAWS. The remaining set of patterns we deal with here focus on synchronization, which is somewhat narrower in scope, but no less important. One of the patterns we'll talk about is a way of being able to take the components you develop that are meant to be used from different concurrency models and allow the locking behavior to be strategized via the strategized locking pattern. So you can plug and play different locking mechanisms that are tailored for the particular use cases in which a component appears. A helper pattern that makes strategized locking and other synchronization type of activities easier to deal with is called scope locking, which ensures that locks are acquired on entrance to a scope and released automatically, irrespective of how a thread leaves that scope. The final pattern we'll talk about in this set is a way that we go and enhance the use of strategized locking by ensuring that components that have been genericized and strategized with respect to their synchronization properties can do this in a very lightweight manner using the thread-safe interface pattern. These patterns, as you'll see, will give us the ability to be able to do various kinds of things, make the system easier to work with, and able to port to a much wider range of platforms when we combine them with various types of frameworks. So to summarize this particular section, the POSA 2 patterns direct developers towards strategic architecture, design, and programming elements of concurrent and network software. If you focus on these strategic elements effectively in your solutions, then it helps to resolve many of the vexing, accidental, and inherent complexities that would otherwise plague your solutions. We'll see that these patterns can be applied to many other things besides web servers, but this allows us to be very concrete in what we're focusing on. Another thing we'll do with the POSA patterns is it'll make it possible to be able to direct developers away from the unhealthy preoccupation with the low-level concurrent and networking operating system mechanisms. It's always important to have a solid grasp of how to do these kinds of low-level concurrency and networking mechanisms. But keep in mind that these are primarily tactical in nature. If you get the architecture right, that's the most important thing. If you are an expert at programming p-threads or sockets, but the architecture of your solution doesn't work, doesn't scale, isn't correct, isn't going to be able to deal with the performance issues and reliability and security issues, then all the great programming in the world won't save you. Naturally, it's important to have both a strategic and tactical grasp, and we'll focus on those kinds of things throughout this discussion. Finally, by combining the POSA 2 patterns with patterns from the Gang of 4 book, the POSA 4 book, other volumes of other books, and other sources of material on patterns, it will allow us to be able to develop much more powerful and comprehensive pattern languages. And we'll look at a number of those examples as we go through the rest of this section.